It is a ritual that we repeat twice a day, often without even thinking about it. But before arriving on your toothbrush, this fresh and minty paste has crossed an industrial journey of surgical precision, from the selection of microscopic abrasives to the mystery of the colored stripes that never mix inside the tube. Today, Made In Cognito takes you behind the scenes of toothpaste manufacturing. Forget artisanal mixtures. Here, we are talking about cutting-edge chemistry and infernal production rates. To understand the tube sitting on your sink, we first have to look at what came before it, because for thousands of years humanity has been obsessed with white teeth, but the methods were terrifying. Ancient Egyptians used a powder made of crushed ox hooves, burnt eggshells, and pumice stone. The goal was simple: scrape the teeth clean using brute force. Fortunately, modern chemistry has replaced crushed bones, but creating the perfect paste is a complex balancing act. A typical toothpaste formulation contains 5 main families of ingredients. First, the abrasives. They make up about 50% of the paste. Today we use hydrated silica or calcium carbonate. The engineering challenge is critical here. The grains must be hard enough to remove plaque, but soft enough not to scratch your enamel. It is a measurement calculated to the micron. Second, the humectants. Have you ever wondered why toothpaste doesn't dry out like cement when you leave the cap off? That is thanks to sorbitol, or glycerin. These molecules hold on to water, keeping the paste in a perfect gel state. Then we add the binders to give it structure, and surfactants, like sodium lauryl sulfate, to create foam. Interestingly, foam doesn't technically clean your teeth, but it helps disperse the flavors and gives us that psychological feeling of cleanliness. Once the recipe is set, it is time to move to the factory floor. And this is where the biggest enemy of toothpaste appears: air. Welcome to the mixing deck. These massive stainless steel tanks can hold up to 3,000 liters of product. The mixing process is critical. If you simply stirred these ingredients in an open bowl, millions of microscopic air bubbles would get trapped in the paste. This would be a disaster. Oxygen promotes bacterial growth and destroys the density of the product. That is why these machines are vacuum mixers. Powerful pumps suck all the air out of the tank, creating a total void. The ingredients are mixed in a vacuum. This ensures the final paste is dense, smooth, and perfectly preserved. Before leaving the tank, the batch undergoes a viscosity test. It must be liquid enough to pump through pipes, but solid enough to sit on your toothbrush without dripping. This is the science of rheology. Before sending the paste to the filling line, we need to talk about the container itself, the tube. It looks like simple plastic, but it is actually a technological shield. If you cut a tube in half and looked at it under a microscope, you would see multiple layers. It is a laminate. Often, it creates a sandwich: plastic on the outside, plastic on the inside, and a microscopic layer of aluminum in the very center. Why aluminum? Because mint flavor is volatile. Without this metal barrier, the mint aroma would escape through the plastic and oxygen would get in. In less than a week, your toothpaste would lose its taste. This multi-layer armor ensures that the first squeeze tastes exactly as fresh as the day it was made. Now, we arrive at the question everyone asks. How do they get the stripes in the tube? And why don't they mix together? Here is the secret. The stripes are not painted on the inside of the tube. They are created at the very last second, right here, at the filling nozzle. The machine is fed by separate tanks, one for the white base and others for the colored gels. The nozzle acts like a multi-channel syringe. It injects the white paste through the center and the colored stripes through tiny ports on the sides. Because the paste is thick and viscous, it flows in what physicists call laminar flow. The layers slide next to each other without turbulence. They don't mix. They simply sit side by side, locked in place, waiting for you to squeeze. But wait, even after the tubes are filled and sealed, they are not allowed to leave the factory, not yet. The pallets are moved to a restricted area called the quarantine zone. They will sit there for several days. Why? Microbiology. In the lab, technicians are cultivating samples from the batch, waiting to see if any bacteria grow. Remember, toothpaste goes directly into your mouth. The safety standards are as high as in the food industry. Only when the lab gives the green light are the pallets unlocked and loaded onto the trucks. The speed here is blinding. These lines can fill and seal over 300 tubes per minute. Notice something strange? The tubes are filled from the bottom. The cap is already on. Once filled, the open end is heated and crimped shut by heavy jaws, stamping the expiration date at the same moment. From a mix of powders and gels to a sealed product ready for shipping, the entire process takes less than 24 hours. So, the next time you brush, remember, you aren't just holding a hygiene product. You're holding a masterpiece of vacuum engineering and fluid dynamics. This was Made in Cognito. Don't forget to subscribe for more insights into how our world is made.